Good morning, everyone. Today I will discuss our research on enhancing biological concept acquisition for students with disabilities through VR and AR technologies, conducted by Salimova Sarvinos Farkhodovna. Traditional biology education often poses significant barriers for students with disabilities. These barriers stem from heavy reliance on abstract concepts, static diagrams, and physical lab limitations. Inclusive education is crucial, and recent developments in VR and AR present unique opportunities to overcome this challenge through immersive and interactive learning experiences. Students with disabilities face particular difficulties when trying to visualize abstract biological processes using conventional methods. Traditional teaching approaches often fail to meet their diverse learning needs, significantly limiting their academic performance and engagement. Our research had two primary goals. First, to develop and evaluate VR and AR models grounded in universal design for learning and cognitive load theory principles. Second, to assess the model's effectiveness on students, learning outcomes, retention capabilities, and engagement levels. The theoretical framework underpinning our study includes universal design for learning, emphasizing flexibility and accessibility for diverse learners. Cognitive load theory aimed at reducing unnecessary cognitive strain, and design-based research focusing on interactive and practical application of theoretical principles. Our study used a mixed methods approach involving 1,217 students across 4 pedagogical universities in Uzbekistan. Participants were randomly assigned to experimental groups or control groups to evaluate comparative outcomes systematically. We developed a VR model titled Immersive Journey Inside a Cell using cutting-edge devices like Meta Quest 3 and HTC Vive Pro 2. The model incorporated accessibility features such as special audio descriptions, haptic feedback, and high contrast visuals to accommodate students with varying disabilities. Our AR model, interactive photosynthesis, utilized advanced technologies such as iPad Pro with LiDAR and Microsoft HoloLens 2. Students could interact with virtual elements via animations and adjust experimental parameters, accompanied by comprehensive subtitles for inclusivity. An expert panel consisting of biology educators, UX UI designers, and students with disabilities conducted evaluations. Methods included Likert scale questionnaires, heuristic evaluations, and the Think Aloud protocol, leading to interactive enhancements and improvements of the models. Quantitative analysis revealed significant improvements in biological concept acquisition among the experimental group. Furthermore, students demonstrated substantially enhanced long-term retention of knowledge with 92% 68.3% retention in VR and AR groups versus 73.8% in traditional groups, indicating strong educational effectiveness. Cogans 1.83. Detailed analysis across disability categories highlighted notable improvements. Students with mobility and hearing impairments showed remarkable gains, benefiting significantly from the multimodal and interactive nature of VR and AR experiences, with statistically significant ANOVA interaction effects. Qualitative findings underscored increased motivation, reported by 91.7% of participants, and significant enhancement in spatial understanding. Key feedback themes included a greater sense of autonomy, improved peer collaboration, and reduced cognitive barriers. Consistent positive outcomes were observed across all participating institutions, irrespective of varying technological readiness levels. This consistency highlights the potential for broad implementation across diverse educational contexts. Despite promising results, we identified several challenges, included technology accessibility issues, the need for comprehensive teacher training, customization requirements for individual disabilities, and technical maintenance. We recommend addressing these areas for more effective future implementations. In conclusion, our research demonstrated that VR and AR technologies significantly enhance inclusive biology education. Emphasis should be placed on design principles such as multimodality, adaptability, scaffolding, cognitive load minimization, and safe exploration. Future research should explore further applications in other scientific fields and develop AI-driven adaptive education models. In this slide presents the complete list of references utilized throughout our research. Please feel free to review these sources for a deeper understanding of the foundational concept discussed today. And thank you for your attention. I welcome your question and discussion. Thank you.